Okay, so today's video is going to be about Pythagorean theorem. We're going to answer the question, how do I find the missing side length of a right triangle? And then how do I use Pythagorean theorem to classify a triangle? So make sure you have both of those questions down in your journal. So to start, we're going to refresh on Pythagorean theorem. So remember that it is a squared plus b squared equals c squared. So you're going to take the side length a here, a squared is the green box, b squared is the blue box, and then c squared is the red box. And so when we compare the areas of a squared and b squared, when we add those together, they are equal to c squared, and that's always true. But it only holds true for right triangles. So we're going to use Pythagorean theorem to find missing side lengths. So for the first one, I have 7, 4, and x, where x is the hypotenuse, so that's what I'm missing. So I'm going to say 7 squared plus 4 squared is equal to x squared, because I know it's a right triangle. 7 squared is 49. 4 squared is 16, and then still x squared. 49 and 16 makes 65, so I get x squared. To undo the squared, I need to take the square root. So I'm going to take the square root on both sides, and I get x equals the square root of 65. I can't simplify 65. It has no perfect squares that go into it. So I'm just going to leave it as x squared equals the square root of 65. For our next one, we have these tick marks here. So each side is x. So I'm going to set that up as x squared plus x squared equals 10 squared. So when I have x squared plus x squared, that's actually 2x squared, and 10 squared is 100. So I'm going to divide by 2, and I get x squared equals 50. So now I'm going to take the square root of 50 and of x squared, and I get x equals the square root of 50. But in this case, 50 is actually 25 times 2 in the square root, and the square root of 25 is 5. So x equals 5 root 2 in this case. And then our last example over here, I'm not looking for the hypotenuse anymore. I'm looking for the missing side length. So it's going to look a little bit different. So I'm going to have 9 squared plus x squared equals 17 squared. So 9 squared is 81, x squared, still x squared, and 17 squared is 289. So I'm going to subtract 81 from both sides, and I get x squared equals, let's see, 208. And then again, I'm going to take the square root, showing you in red again, take the square root on both sides, so x equals the square root of 208. But 208 factors into 16 times 3. So the square root of 208 is actually 16 times 13, sorry. And the square root of 16 is 4. So in this case, x equals 4 times the square root of 13. So now we've used Pythagorean theorem to find any missing side lengths that we have. Now we're going to use Pythagorean theorem to classify our triangles given 3 side lengths. So we talked about this in class. If you have a squared plus b squared equal to c squared and Pythagorean theorem holds true, you have a right triangle. If c squared is greater than a squared and b squared, you have an obtuse triangle. And if c squared is less than a squared and b squared, you have an acute triangle. So we're going to use that information on our next 4 examples. So for example number 1, we're just going to plug it in. So we're going to have 8 squared. We're going to have 8 squared plus 11 squared, and then we don't know if it's greater than, less than, or equal to 13 squared. So 8 squared is 64, 11 squared is 121, 13 squared is 169. 64 and 121 makes 185, which is in fact greater than 169. So we have an acute triangle here. On our next example, we're going to do the same thing. 5 squared plus 12 squared, and then we don't know, 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is still 169, 144 and 25 makes 169. So in this case, they are equal, which means it is a right triangle. So we're going to try it again, but this time we have radicals as our side lengths, so we're going to do the same thing. So I have the square root of 2 squared plus the square root of 6 squared and the square root of 11, but I don't know if it's greater than, less than, or equal to. Now when you square a square root, they undo each other. So the square root of 2 squared is going to be 2. The square root of 6 squared is going to be 6, and the square root of 11 squared is going to be 11. 6 and 2 makes 8, which is less than 11, so in this case we have an obtuse triangle. So we're going to try it one more time, and in this case we're going to have some fractions. So we're going to do the same thing, 3 over 2 squared plus 11 over 6 squared is, we don't know, greater than, less than, or equal to 13 over 6 squared. So I'm going to switch each step colors, that way you can see what I'm doing. So when you square a fraction, you need to square the top and the bottom. So 3 squared is 9, 2 squared is 4, 11 squared is 121, 6 squared is 36, and I'm going to put our little box there. 13 squared is still 169, and 6 squared is 36. Now, we need to add 9 over 4 and 121 over 36, but we're going to have a common denominator to do that. So it looks like the common denominator that I need to use is 36. So I'm going to do some scratch work over here. 9 over 4, I need to change it to have a denominator of 36. So I'm multiplying by 9 at the bottom, so I need to multiply by 9 on the top, so 81. So this is actually 81 over 4 plus 121. I'm sorry, not 81 over 4. 81 over 36. Let me fix that. 81 over 36, and then 121 over 36. And we're going to compare that to 169 over 36. So 121 and 81 is 202 over 36, and that is greater than 169 over 36. So we have an acute triangle. So you can still do this with fractions, you just have to make sure you have a common denominator. So that's the end of the video. Make sure you have all the examples down in your journal.